Section 6.4, trigonometric functions continued. Our objectives are to define the trigonometric ratios in the coordinate plane and also to define the trig functions in terms of the unit circle, which we've already done, and we've talked about the unit circle and how to get the coordinate ordered pairs and the radians and degrees, etc. So if we have our circle and it says let t be a number, a real number, and p be the point where the terminal side of the angle in t radians in standard position meets the unit circle, which that would be this point right here, which we're going to call P. Remember we said that that was the point X comma Y, and then we showed that you can figure out, if this is, we're calling this angle T right here, you can figure out the trig ratios for that angle and that point by just drawing a line down here and making a right triangle. So you know this distance is X, this is Y, and instead of saying R, we're saying R is going to be equal to 1 because we're using the unit circle. And in this case, then that means that the sine is equal to opposite over hypotenuse, because remember, so TOA, if you forget, so sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent is what that means. And so we have the sine of t is equal to y, cosine t is equal to x, tangent is going to be y over x, and if sine and cosine we already know is x and y, then we can really say that the tangent of t is equal to sine t over cosine t. It means the same thing. Cosecant of t is a reciprocal function for sine, so 1 over y. Or remember we said before that that's the same thing as saying the cosecant of t is equal to 1 over the sine t, because they're reciprocal functions. So we talked about that earlier in the year. So secant is going to be 1 over x, or we can write that as the secant t is equal to 1 over cosine t, and cotangent would be then, of course, x over y, and so cotangent you can also say is cosine t over sine t. So those are all things that you want to know, and as I said before, if you forget, you can always make a circle and a triangle and figure it out from there. So that's how we also know that the x-coordinate point is really going to be the cosine of the angle, and the y-coordinate is the sine of the angle, and that's how you can get that xy ordered pair. Now, the values of the trig ratios can be positive, negative, or 0 depending on which quadrant the point P is in. The angle can be measured in degrees or radians, as we talked about. Because R is always positive, the sine and cosine are defined for all angle values. And if you look at then tangent, cosecant, secant, and cotangent, those are not defined for all values because here we have x in the denominator, and x can't be then equal to 0 for tangent. Here y can't be equal to 0, x can't be equal to 0, and y cannot be equal to 0 because y, we can't divide or have 0 in the denominator. Coterminal angles will have the same trig ratios, and of course we've talked about this with coterminal angles. So let's say I had, let's use 30 degrees. So if I have 30 degrees, which is the same thing as, so I'm going to write that here. So 30 degrees, remember, is the same thing as pi over 6 in radians. So if I do the sine of 30 degrees, we now know that the sine of 30 degrees is equal to 1/2 using our unit circle that we have memorized. If I do a coterminal angle with that, so something that's coterminal means you're adding or subtracting 360 degrees, or if you're in radians, you're adding or subtracting 2 pi. So if I go all the way around my circle and back to here, I've added one whole rotation and plus the 30 degrees. So that would be the sine of 390 degrees. If I do the sine of 390 degrees, because I still have the same initial side and terminal side, I know that's still going to be equal to 1/2. Even if I kept going around and around as many times and kept landing on the same terminal side with the same initial side, I would still end up with that being equal to 1/2. If I go the negative direction, so if I start at the x-axis and go around this way, remember that you're taking the 30 degrees minus 360, which would be negative 330 degrees. So, oops. So the sine of negative 330 degrees is also equal to 1/2. And if I keep subtracting 360 each time, I will still end up with the same thing. So again, coterminal angles will always have the same trig ratios. Tangent and secant are defined for all angle values except for x equals 0, which we talked about, and cotangent except for and cosecant for values except for when y is equal to 0. So just real quickly, if we look at the cotangent and cosecant, this is x over y, and this one would be 1 over y. And for this, that means y can't be 0, and remember y is really sine, which we showed from our circle up above. It says for what real numbers from 0 to 2 pi, and remember this is interval notation right here, so including 0 and 2 pi, does the sine of t equal 0? So if you think about your unit circle, we want to think about where is the sine going to have a value equal to 0. That means where is your y value going to be 0? Well, I know that my y value is 0, sorry, not there. My y value is 0 here and here, so this is 0 degrees, and then if we go all the way around to here, this is going to be pi, and then if I go all the way back around, this would be 2 pi, so that would be 0, pi, and 2 pi. We're going to skip this question for right now. And if I wanted to do tangent and secant, so this is y over x, and this one is 1 over x, so that means that x can't be 0 or cosine can't be 0. So now we need to figure out where is the cosine 0. So the cosine is 0 here at pi over 2 and down here at 3 pi over 2. And again, those values are from our unit circle. So my solution would be pi over 2 and 3 pi over 2. And we're going to skip this one for right now. Now, for the next example, it says we want to find the 6 trigonometric functions of the angle theta whose terminal side passes through the point 2, negative 1. Now, if we want to figure out the trig functions whose terminal side passes through the point 2, 1, the first thing you want to do is actually draw this out on your coordinate plane. So I have the point 2 and down negative 1, and terminal side passes through there, so the terminal side would be going this way. If I want to find the trig functions of the angle theta whose terminal side passes through here, remember you're going to always make your triangle with the x-axis, so this is going to be my right triangle. That means right here is going to be theta, so remember theta is always going to be the positive acute angle made with your terminal side and the x-axis. So if you're in the other quadrants on the other side, you'd use the negative x-axis. And we know that this is 2, this is negative 1. That means I need to figure out what the length from here to here is, so your radius. So in order to figure out that, we're using our Pythagorean theorem. So r squared is equal to 2 squared plus negative 1 squared. So that would give me a value of r being equal to, r squared equal to 5. So r is equal to the square root of 5. And remember, r is always a positive value. That's why I'm not going to do plus or minus the square root of 5. Now that I have that, I can figure out my trig ratios. So again, so SOHCAHTOA, so the sine of the angle that we have would be opposite, which is negative 1, over hypotenuse, which is root 5, so negative 1 over root 5. We want to rationalize the denominator, because we don't like to have radicals in our denominator. So that gives me negative root 5 over 5. So that would be for the sine. So then the cosine of theta would be equal to adjacent over hypotenuse, which is root 5. So then again, rationalize the denominator. And we end up with 2 root 5 over 5. Then the tangent of theta would be equal to opposite over adjacent, so negative 1/2. Then I want to find the reciprocal functions, because it says find 6 trig functions. So for sine, the reciprocal function is, of course, cosecant theta. So the cosecant of theta, I would just use this right here. So flip that, and you get root 5 over negative 1, so negative root 5. Then for cosine, the reciprocal function is the secant of theta. So again, I'm going to use this right here, so the radical's on top, so root 5 over 2. You could flip this answer right here that we found, but if you flip that, then you'd have to rationalize the denominator again, so it's just easier to use what we had in the beginning. And then for tangent of theta would be the reciprocal function is cotangent theta, which would then be 2 over -1, so -2. So those are all your 6 trig functions for the angle theta, whose terminal side passes through the point right here, which we said was 2, -1. The next thing we've talked about a little bit already, the signs of a trigonometric functions in the 4 quadrants can be determined easily from the definitions of the functions. So a simple way of remembering them is by using all students take calculus. So again, we've talked about this some with our unit circle, but in the first quadrant, which is here, this would be the second quadrant, this is the third quadrant, and the fourth quadrant. Remember that in the first quadrant, your x and y value are both positive. So if your x and y value are both positive, well, if you think about earlier when we were finding, if you go back up here, remember for these values, we're using x and y. So basically we're looking at all of this right here, and we're trying to figure out, is it going to be a positive trig function, negative, by looking at those signs. So in this first quadrant, all your trig functions are going to be positive because x and y are both positive. So cosine theta is positive, sine theta is positive, tangent theta is positive, and that means the reciprocal functions are also positive. In quadrant 2, we have a negative x value and a positive y value. So if you have a negative x value, remember that we have cosine theta comma sine theta. So x, that means, is negative. If x is negative, then cosine is not positive in quadrant 2, and also tangent can't be positive in quadrant 2. The only thing that's positive would be the y coordinate, so sine theta is positive here, and its reciprocal function, so sine and cosecant theta would be positive. And I guess I should write the reciprocal functions here, so cosine, secant theta, cosecant theta, and cotangent theta. Now in quadrant 3, we have negative x and negative y. So if you have negative x and negative y, cosine's negative, sine's going to be a negative trig ratio, but sine over cosine for tangent and cotangent would be positive. So here we know that tangent of theta is positive trig ratio, and cotangent of theta is a positive trig ratio. And in the last quadrant, we have plus and minus. So now notice that your x coordinate is positive, so that means cosine theta is going to be a positive trig ratio, and its reciprocal, which is secant. So these would be positive. All the other trig functions would be negative in that quadrant, and same thing for each of the other ones. Why do we need to know this? Because this helps us, if we're given certain information, to solve a problem. And we'll skip this one part for right now, but let's go ahead and look at this example. It says, given the sine of t is equal to 4/5 and the tangent of t is less than 0, we want to find the cosine t and cosecant of t. Now here we do have enough information to solve this based upon the fact that we can figure out which quadrants we have, which quadrants our trig functions are positive or negative. So all students take calculus is how I remember that. A stands for everything, S stands for the sine, it's reciprocal, T tangent, reciprocal, C cosine, and reciprocal. So for this one, it says that the sine of t is 4/5, so the sine is positive trig ratio, and then it says the tangent is going to be a negative value because it has to be less than 0. So tangent is not negative in this quadrant, nor is it negative in this quadrant, so it can't be quadrant 1 or quadrant 3. Now let's look at the other two. So again, tangent has to be less than 0, and sine is positive. Well, sine's not positive in this quadrant, so that means that we have to be in the second quadrant. So that's where I'm going to make my triangle. So if I make my triangle sine, this is t, because you always make the angle with the positive acute angle that's made with the x-axis. So here we have sine, which is opposite over hypotenuse, which is 5, and that means we need to then solve for this distance right here, which I'm going to call x. So we have the hypotenuse squared equals 4 squared plus x squared. So 25 minus 16, so 9 is equal to x squared. So x would be equal to 3. But if you get 3, look at what quadrant you're in. You are in quadrant 2. So if we're in quadrant 2, notice your x value on the negative x-axis. So you have to remember to make this a negative value. So this is, oops, so this is going to be equal to negative 3. And it makes sense because, again, you're in the second quadrant. So I already have the sign. It just says we need to find cosine and cosecant. So the cosine of t would then be equal to adjacent over hypotenuse, and the cosecant of t I can just use by doing the reciprocal of this. So the cosecant of t would be 5 over 4. If I wanted to find the tangent, which it didn't ask me to, but I can, so the tangent of the angle would then be equal to opposite over adjacent. And of course I can find the reciprocal functions just by flipping those. So that's why it's good to know all students take calculus and know which quadrants the trig functions are positive in and which are negative, because sometimes it helps us solve given certain information. Going back to here, it says state whether each value is positive, negative, or 0. So if I want to state whether each value is positive, negative, or 0, I need to first figure out what quadrant we're in. So looking at A, I have cosine of 75 degrees. So cosine of 75 degrees. So this is the angle that we would have in standard position. That means we are in quadrant 1. So all students take calculus in the quadrant 1. Cosine 75 degrees is going to be a positive value. For the next one, we have the sine of 3 pi. So I need to figure out, okay, 3 pi. Well, I know all the way around my circles is going to be 2 pi. So this starts at 0, and I know this is pi, and back around would be 2 pi, because we talked about that for a circle. So I would be going all the way around. Once would be here, 2 pi, and then add another pi would give me 3 pi. So that means my terminal side would be ending right here, which is on the negative x-axis. So if we're on the negative x-axis, the sine coordinate, of course, is y, which would be negative 1, 0. So this is equal to 0. Then if we look at the cosine of 7 pi over 4, so again, I'm going to want to draw this, and so hopefully by now you have your unit circle memorized and you know where 7 pi over 4 is on your unit circle. So 7 pi over 4 is in quadrant 4, which would be down here. So this would be what my picture would look like in standard position. So since we're in quadrant 4, again, all students take calculus. And we're talking about cosine. So cosine is positive in quadrant 4, so that means this is going to be positive trig ratio, and we should know that from our unit circle. So then if we look at B, for B, I know this is going to end up being in quadrant 3 because we're doing the negative 3 pi over 4, normally positive 3 pi over 4. So if I had from here to here, this would be positive 3 pi over 4, but we want negative, so we're going in the negative direction, which means that it's going to be down here. So this would be negative 3 pi over 4, which is what we want. So that means we're in quadrant 3, because remember, negative angles go in the clockwise direction. Since we're in quadrant 3, sine, all students take calculus, so tangent and its reciprocal, the only one's a positive in quadrant 3, so the sine trig ratio here is going to be negative. And again, that's why it's helpful to kind of go through and be able to use all students take calculus and know whether it's positive or negative. Now, for this next part that we have right here, we're talking about the reference angles again. We've talked about reference angles in class, so I want you guys to see if you can do this on your own. And then for the next part, It says use a calculator to find the sine, cosine, and tangent of each number and round your answer to the nearest hundredth. Use the signs to determine what quadrant the terminal side is. So I want you guys to also see if you can do this on your own. Remember to change your mode in your calculator. Change it to radian mode. How do I know I'm in radians? Because if you look at each A, B, and C right here, there is no degree symbol. So make sure to change your mode into radians and then see if you can figure out what the calculation is equal to. So you guys do this one. And we'll talk about that in class, and we'll also talk about the last part as well.